Hey guys, welcome back. We're in day 9 still, talking about integrated rate laws. We're going to do problem number 90. I like this one. The hydrolysis, so right away that word, right? This word hydrolysis means it's a reaction with water. So the hydrolysis of sucrose, which is C12H22O11, into glucose and fructose in acidic water has a rate constant K of 1.8 times 10 to the negative 4 per second 1 at 25 degrees Celsius. Assuming the reaction is first order in sucrose, all right, determine the mass of sucrose. So there's what we're doing. Determine the mass of sucrose that is hydrolyzed or reacted when 2.55 liters of a 0.15 molar sucrose solution is allowed to react for 195 minutes. So we have that much, that concentration. Okay. So first order, natural log sucrose at time t equals negative k t t0 C12H22O11 C12H22O11. Okay. Now, I would probably use the E form here. And the reason we would use the E form is because we're looking for how much is left, right? So what do we need to know? Well, I have 195 minutes and K is in seconds, so we're going to have to fix that. Alright, so C12H22O11 at time t, which is 195 minutes, is equal to the original concentration of 0.150 molar at time 0, E to the negative K, which is 1.8 times 10 to negative 4 seconds negative 1, T, 195 minutes, and that's not going to work. So we need to do something that we know that 1 minute is 60 seconds. All right, that'll work for us now. Okay, that'll work. So that'll give us the concentration of sucrose at time t of 195 minutes to be what? Well, let's look here. Clear. I have 0.15 molar times second log negative 1.8 times 10 to the negative 4 times 195 times 60. I believe that's right. I should get 0.018 molar. 0.018 molar. And sig fig wise, I get to have just 2 because of K. So 0.1018. 0.018 molar. Okay. Is that my answer? The answer is no, that's not my answer. Why is that not my answer? Because I want to know how much hydrolyzed, how much reacted. This is how much remains. So that's the difference. Now, technically speaking, we should probably do it by figuring out the moles and grams of sucrose in 0.15 molar and having the moles and grams in 0.18 molar and then subtracting the masses. However, because we're only going to have 2 sig figs here, we could take the molarities and subtract the molarities and do it that way as well. So what do I mean? So if I'll do it both ways. So option 1 here, option 1, I take my volume of 2.55 liters of sucrose, C12H22O11, and we're going to multiply. We know the molarity was in 1 liter. Well, let's use the blue because I've been using the blue. 1 liter of C12H22O11. I had 0.150 moles of C12H22O11. And then we know that 1 mole of C12H22O11 happens to weigh 342.34 grams. So that means initially, I had 16 grams of C12H22O11 in that original conditions, original mixture. All right. Now, in 2.55 liters of C12H22O11, my new concentration is 0.018 moles of C12H22O11 per 1 liter. And multiplying by the molar mass, same molar mass, of course, 342.34 grams. I end up with I did this backwards. This is 16 grams of C12H22O11. This is 131 grams. Sorry about the confusion. Alright, so the difference would be 131 grams minus my 16 grams to give me an answer of 115 grams of C12H22O11 reacted. Or, option 2 is I take the original amount of 0.15 molar, 0.150 molar, and we subtract my ending concentration of 0.018 molar, and we learn that 0.15 minus 0.018 is 0.132. 0.132 molar C12H22O11 reacted. Now, if I take a I'll use the same color, 2.55 liters of C12H22O11, right? Because it's the same, we're assuming the volume's not changing. That's the assumption we're making. We know that we have in 1 liter of C12H22O11, we have 0.132 moles C12H22O11. And then we have 342.34 grams of C12H22O11 in 1 mole. And that, do that math, you get 2.55 liters, right, times 0.132 times 342.34. And I get 115. C12H22O11 reacted. And that is number 90. So hopefully that makes sense. Sorry about the little confusion of the masses there. And that's number 90. Alrighty.